Here we have a problem on compound interest. Okay, let's go with the information. And now opens a bank account with an initial deposit of $1,000. The bank account will earn 3% interest compounded annually for the first 5 years, after which it will earn 7% interest compounded annually. Which of the following expression represents the total amount in the account after T years? Okay, first let me draw a line segment which represents a total time period T years. So on this line segment, first I mark the 2 points A and here B. So the length of the line segment, complete line segment AB represents the total time period T years. And also I mark another point on this line segment, say C, and the length of the line segment AC over here represents the first 5 years. Let me write it over here, first 5 years. Then what does the length of the line segment CB represent? So it's clearly T negative this time period, that is T negative 5 years. Let me write it. Okay. And the question says for the first 5 years, the account earns 3% per interest, 3% interest compounded annually. So for the deposit, $1,000. Okay, first let me write the formula over here for compound interest. So that is A1 equals to P times 1 positive R over N to the power of NT. Okay, now let's understand the components of this formula. So usually we write A, but here I write A1. There is a reason for that. I'll tell you later. So here A1 represents the value of the deposit after T years. So the T over here is a time period, so for which the money is deposited, and always it has to be in years. So A1 represents the value of the deposit after T years, and P represents the principal or the initial value of the deposit, and R is the rate of interest, and N is the number of times the interest is being compounded per year. So since interest is compounded annually, so that is the interest is compounded once in a year. In this case, N is equal to 1. In case the interest is compounded semi-annually, that is it will be compounded once in 6 months. Then in a year, it will be interest will be compounded 2 times. In that case, N will be 2. If interest is compounded quarterly, so that is 4 times interest is compounded per year. In that case, N is equal to 4. But here interest is compounded annually. That is once in a year interest is compounded. So since N represents the number of times interest is compounded in a year, it is just 1. Okay, now let's find the value of the deposit after the first 5 years. That is, I'm going to find the value of the deposit at the position C. That is at the end of 5 years or after 5 years. So for that, what I have to do is I have to plug in the values over here. So I said P is the initial deposit or the principal. So here the principal is $1,000. We can plug in now 1,000 for P, 1 positive. R is the rate of interest. So usually that we write that one in decimal form. So 3%. The decimal form of 3% is 0.03. That is, you have to divide 3 by 100. So and the number of times interest is compounded per year. In this case, it's 1 because it's compounded annually. Again, here N is 1 and T is number of years. So here we have 5 years. I have to multiply it by 5. Then A1 equals to 1,000 times. So when I divide this 0.03 by 1, it's still 0.03. When I add this 0.03 to 1, so I'm getting 1.03 to the power of 1 times 5 is 5. So this is the value of the deposit, $1,000 after 5 years. That means like the C represents the end of first 5 years. At this position, the value of the deposit is 1,000 times 1.03 to the 5th power. At the position A, the value of the deposit is just $1,000. So that's the initial deposit. Since AB represents the complete time period T years, the point B over here represents the end of T years. So this is where we have to find the value of the deposit. That is the total amount in the account after T years. Okay, for this period, that is for this T minus 5 years, this is the principal. And now we have to find the value of the deposit at the point B, that is after T years. So for that, again, we have to use the same formula. This time, I assume A2 as the value of the deposit after T years. So the formula is the same. That is P times 1 positive R over N to the power of NT. So here, P is the principal, but this time the principal is the value of the deposit after 5 years. So that is 1,000 times 1.03 to the 5th power. So this is the principal for this period, and times 1 positive. So here rate of interest is this time 7%. So 3% rate of interest is given only for the first 5 years. After that, we have 7% rate of interest. That is for this time period. Okay, so if I convert the 7% to decimal, it will be 0.07 divided by, still n is the same one, because for after 5 years also, interest is compounded annually, that is interest is compounded once in a year. So n is 1, number of times interest is compounded in a year, to the power of, again, n is 1. So here t means a time period for which the money is deposited. Here the time period is t minus 5. So we have to multiply this 1 by t negative 5. So then we get 1000 times of 1.03 to the fifth power times, when I divide this 0.07 by 1, it's still 0.07. When I add it to 1, then we get 1.07 to the power of 1 times t negative 5 is t negative 5. So this is the value of the deposit or the total amount in the account after t years. So we find this stuff, that is 1000 times 1.03 to the fifth power times 1.07 to the power of t negative 5. In option C, the correct answer choice for this question is option C.